Hi and welcome back to the lab. Today here on the bench we have a MFJ 994 BRT, which is a 600 watt PEP automatic antenna tuner. And here's the thing, without this little bias T, which is delivered together with the BRT, it is working just fine. But if we connect the bias T to the unit, then it won't work in any way. So let's look into it and let's see what the problem is. Yeah, and here is the unit, and you all know that an automatic antenna tuner will placed to the feed point of the antenna. And that is then sometimes a problem because you do not have a 12 volt DC supply directly at your antenna feeding point. So therefore it is really a good idea if you use a bias T that you will be able to deliver over your antenna cable your needed 12 volt DC. And therefore we have this bias T, which combines, as you will, the DC and the RF, and at the antenna tuner itself it gets separated once again to be able to deliver the supply voltage on the on one hand, and on the other hand, of course, the RF needs to go through the MFJ to be able to do the tuning job. Okay, and let's go directly into it. Let me prepare a little test setup where we have a radio to drive the MFJ, and then let's see what we can find. Right, so here we have our setup, and what we can see is that of course here our unit has a direct DC input. If you have a power supply right at the feed point of your antenna, okay, and here you have the input from our transceiver, and this is then of course the antenna connector, which is in our case for the moment in time the dummy load and our LP500 to read the power and the SWR. And of course you can put a long wire antenna to it as well, and this is the earth connector, so everything nice as you would expect it. Right, so now first we check it without any DC to the unit, and under that circumstances normally the signal should go through. Our radio is set to FM, that we have at least a carrier, then it is easier to evaluate what we have. Okay, and then of course I have there our LP500, and let's see if I now, without any DC press here, can we see it, our PTT, and yeah, so that looks nice. So the radio is set by the way to 5 watt output power, and you see that the SWR is 1, which is fine, and of course we have a little we have a little attenuation through the antenna tuner, so that is normal. It is not entirely 5 watt, but anyways, it looks good. Okay, so let's put DC to it, and let's see if that makes here anything, but no. Nice. Oh, hello. So that is the first thing what is not good. So you have seen we connected it and it didn't work, and I was wiggling here a little bit, and then maybe you heard it, it was clicking, which are of course relays which are here. There are tons of relays in an antenna tuner like this here. But what we see as well is that the antenna tuner is pulling 27 milliamps, which is a kind of showing that it is yeah, somewhat operating. And when I press PTT, so now you see another relay might have switched, and you see it is 67 milliamps, which seems to work. And also here our power meter is displaying that our power is getting through, so no problems whatsoever. Right, so what I've now done is I've taken here my test dummy, which I use to align SWR bridges, and this here is 3:1, so that is so not our 50 ohm dummy load with what we usually use. So now if that is connected to our antenna tuner, let's see what happens if I press now the PTT. Alright, so that is obviously working. So we hear that of course the clicking was doing the tuning, and then you see that now a couple of more relays kicked in, which are finally adjusting the tuner to the right amount, and that is what as well our power indicator, so our amp indicator, is telling us. So from that point of view, everything seems to be absolutely fine, maybe except the fact that there is yeah, so there's something loose. It is not working correct. So that is once again when I wiggle it here, so you see that is not how it have to be. And now again it is switching somehow, which is fine. Anyways, so that has already given us the idea that it is fine. But before we are gonna now put here our bias T into the line, I just want to open our MFJ just to be sure that you know the DC block. I mean, a bias T is nothing else but a DC block. So we need to block the DC to our radio, and we need to have our DC out. And let me see. I think I've seen it here. So you see here RF and DC. So that means here we have our DC pass, and that means on the other side we only have RF in out, which is then our DC block, and that is clear. So we have to avoid that DC gets in our antenna socket of our radio, and the same of course is here with our MFJ. So we have to make sure that it is not only this, so we need a circuit inside our MFJ as well, so a DC block which is avoiding DC to, you know, the tuning part of our circuit. And I have the schematic here from our tuner, and it is important to see that here from the radio side, so we connect here our radio or the transmitter. This is here an SWR bridge, which is not so important now. You see here a bunch of relays which are clicking back and forth and whatever. And important is that on this schematic we do not see the DC block in any way. So therefore, I mean, it is the MFJ 994 which we have, but obviously it is not the BRT version, and the BRT seems to indicate that there is, of course, the DC block in. And I just want to make sure before we do any further testing that there is definitely the DC block in, not that it might have been forgotten to install in factory. Okay, and here we have it, and here you see our antenna input from the radio, and what you see as well is this here is our BRT extension, let me call it that way, because down here we have our blocking DC capacitors, and then here you see, so that is a coil, and then you see down here that then the coil over a diode is connected here to our normal DC input. So we have seen that is here the DC jack which we have used, and yeah, so that is directly here connected to the DC input, and that is telling me that everything is fine. The DC block is given, so we can now connect our bias T here to the input, and then we can check if it is really not working. Okay, so I have connected it here to our tuner, and you see we have a switch here, and we can switch off our DC, and on the other hand I have connected here our wire to the plug, and for the moment in time it is switched off, and that is what we see when we go over there. There is no current flow, so that is clear. Right, so now let's switch it in. Okay, and we directly hear that there is a relay clicking, and we see our approximately 30 milliamps, which we have seen before. So that is clear. And let's see what the reading is if I go here directly to our antenna socket, and we see fantastic. So we have our 12 volt which we feed in, so that is working obviously. And now on the other side here where we have the DC block, if I go into our antenna connector, you see there is obviously nothing, and that is how it should work. So from the DC perspective everything is fine, so I do not see a problem. So that means I can my radio put back here to our input, so we know into direction of our radio there is definitely no DC, which we want. Now let's do exactly the same. We observe our power meter and let's see if it is working. So that is now exactly the same game. So let me press the PTT. But so that is true. Also our DC is present, and HF is also present. We do not see any output to here our LP500. And of course we should connect our dummy load, otherwise it won't work. So once again, okay, again microphone and PTT. Oh wow, we have 0.2 watt output power. Oh, and that is interesting. So let me go down here to the radio. Okay, so let's see if I can get it here on the video. Let me try. So now I press the PTT and have a look. So we get high SWR. Wow. So that makes me wonder what is wrong here with our BRT. Let's investigate that a little bit more. Okay, so let's check the input with our mini VNA to see what our SWR response to this port is. So, these bias tees are known as 3-gate networks as well. So let's see what the response is, and then maybe we understand it a little bit better. So I'm gonna let the mini VNA sweep from 1 to 30 megahertz, which means we are in the shortwave band. So let me start the sweep. Wow. So we do not see nothing. So SWR here we have 10, and that means that the SWR is not even below 10, which really makes me wonder. And when I switch in here my fields, marker 1, 2 and marker minimum, so we see that the SWR best case is 20 and worst case is 108, which is not usable, of course. Good, so let me change the band preferences. So let me sweep the entire, oh wow. So that is now a sweep, an entire sweep over the entire band. And what we can see here is that, at 120 megahertz, it starts to be not good, but maybe usable. But up to 30 megahertz, so you see that is what we have done before. We really have a real high SWR, which means that we definitely have here a problem within our bias T, and we need to have a look inside. Well, I got it open, so I do not know if there is a lid normally over it, and I believe it is. I mean, we have here some holes, so I believe there is a lid. It would be a little bit weird if it is not completely enclosed, so to say. So anyways, what we see here, that is all. So it is not much to it, and I really do not really understand what the problem is. And I mean, again, there is really not much to it. So that is the whole schematic. So you see here we have our radio side where we connect our radio, and here we connect our antenna tuner. So you see here we have our DC feed, and of course the DC can't go into direction of our radio, but it can go to our antenna tuner. So that here are some chokes, and they of course have to prevent that any RF goes down to our DC input, and on the other hand, these capacitors need to let at least our RF through. So that means, considering that we are working here in a 50 ohm system impedance, that means that this configuration here, so the XC, which is, if you like, the AC resistor, have to be much lower than our input impedance, which is 50 ohm. And of course our chokes, on the other hand, have to be much higher, much greater than 50 ohm. So our XL, which is the AC resistor for an inductor. So therefore that is more or less all what we need to know, and the impedance will not get really changed. I mean, there is another formula where we can we can calculate the stop frequency, so the cutoff, the lower cutoff, where we see what you know, the configuration here should be. But I see we have here 10 nanofarad, 10 nanofarad, and 470 nanofarad in parallel, which means these three capacitors get added up, and that means that you know, the XC is really low, and that means there is nothing special, right? Really nothing special except what we have already talking about. So, well, maybe that we have here a cold Tholer joint, or that something went wrong in production. So let us go down to the circuit and let's see if there is something what we see. Well, and of course, if there was a lit, what I believe, then of course somebody opened it up, and it might be, I'm not entirely sure, but it might be that somebody has already tried to reflow the joints here, so that might be. But on the other hand, it does not look like that somebody has already taken out the PCB, and well, that is what we need. And then maybe we have to check here the values if everything is right, but other than that, it really should work. Okay, and here we have the PCB, and still I'm not really sure when I watch this here. What do you think? Is that factory quality? Is it made by hand from MFJ? So I don't know. It looks a little bit yeah, funny. I don't know. Well, anyways, let's check here some basic function. What is that? A wire? Okay. Yeah, let's start with probing here a little bit. Okay, so let's try to understand what's going on here. I mean, we have here the indication on/off on our switch. So normally we would see that the middle pin, or the middle pins, whatever, are connected depending on where the switch is located, on or off. That maybe these both are connected, or if you switch it to the other direction, that then these both are switched in. So that means that is how it should work. And let's verify what we have here. So we are dealing with our beeper finally, and yeah, it's beeping. And let's switch it to this position here, and then we should see. Okay, so that is working, and then we shouldn't have contact here, which we have. And then is it connected together? Yeah, looks like, which seems to be fine as well. And still, okay, so that is fine, because our switch is here on this both contacts. But still, what is this here? So that should not be there. So let me see. Where do I have here ground? So that should be ground here. Yes, it is. It is ground. Let's see. Hey. So that is, yeah, that is odd. So that should not have a ground connection. So what is, I don't understand. What is that? It has a ground connection. Let me see what's going on here. Hello? So that is a connection of our antenna socket, which is completely weird. Let me check it once again here. Now it's gone. And now short between our antenna connector, which is completely wrong. And even so that we have here a wire, and it looks like that it is touching here the copper. So it is all copper, and you can see it here. So that all is ground. Can I? Anyways, so that is totally wrong. So the switch is not connected or should not connected in any way to ground. That is something very wrong. And we can see it here on our schematic that there should not be a connection between ground and any pin here of our switch. So you see, okay, plus, and then they put it in parallel, that both connectors are, yeah, let me say it that way, both are used. So that is how it is drawn here. Anyways, there is definitely no connection to ground, which is definitely wrong. And additional to that, so you can see that this here is our plus from our connector. It's going into the switch, which makes sense, but then you have directly, so unswitched, here our capacitor connected to ground, and then it runs here through our switch. It gets out here, so then
if it is switched on. So our DC should pass through, which is of course totally right. And then we have here our second capacitor running to ground, which is representing this both capacitors, but they are behind our switch, which does not make really any difference. So they put the first capacitor right here from here to ground, which is not wrong. So no problem with that. So that is even under some circumstances better. But then you see here that now over the switch, the plus DC is going here, is running through our coils, and is then here going one way to our capacitor, which would block our DC, and on the other point it is our antenna connector, and you see DC pass, which is true, because over our coils here to the antenna connector is passing through our DC to our automatic tuner, and on the other side, of course, there we have the block, and that is what you see here. So that is finally behind our capacitors. So you see there is definitely not much to it. But why we have here, as you can see, a short between our two antenna connector pins. So that is it's a completely short. It is 0.1 ohm, and that is maybe my wiring here. So so that is definitely not see this. So something is definitely wrong with our switch, and I believe I have to take it out. So that is definitely not right. And what I see here, maybe we have additional to that a dry solar point. I'm not entirely sure, but it looks like. Anyways, I believe it is a good it is definitely good to take here the switch out to understand a little bit better what is going on here. What is going on? So, okay, let's take it out, and then maybe we see it a little bit more clear. Well, before I take it out, there's another thing which is a little bit odd. So the switch is on the on position, which means voltage would go through, and we set a normal switch would work in a way that if it is switched off, this both pins would be connected, and if it is switched in, normally this both pins would be connected. So that means normally you would put your supply voltage in the middle, right? And then if you switch it to that position, you would get your DC to that pin, which then of course would feed your circuit. And when you switch it off, you would put it that way, and then of course the DC would go to nowhere, and the pin which is supplying the circuit would have no voltage. But here in this case, I mean, so that is now off position, and we already found out that as you can hear, hopefully, that these both are connected, and this both here, of course, not. But now, when I switch it in, we find that these both are still connected, and that the third one is also connected, and it is connected over here. So all 3 points are connected, which is very unusual. So another thing which is funny. Anyways, so now let me take it out and let's see if we find what's going on here. Okay, so the switch is out, and now see its behavior. So now, so that is right. So the switch is here, so this both contacts are connected, and the same should be here, and they are not in any way connected to each other. So this, if you like, are 2 individual switches, so this part and this part, and that is what we see. And now when I flip it over, now the upper side should be in contact, which is exactly what it is, and here we should not see any contact. And you remember when it was in, so we had suddenly on 3 pins here a connection, which is of course not right. And now here this upper side is okay. So that means normally you would feed your positive voltage, let me say here, if you flip it down. So here is no contact. If you flip it up, then you have a contact. So that is the normal behavior of our switch, so no problem. But then again, what the heck is this here? So I take it out, and somehow we must have had connections here somehow. Yeah, let's see. I mean, again, I still think it looks like a dry solder point, which we reflow, and then let's see how we can go ahead. And maybe one addition. With the switch off, and we go here to ground, and now to this whatever it is here. You hear that? So we definitely still have a connection to ground, which we shouldn't have. Is that already our problem? Let's go ahead. Okay, so I set it up for testing, and what you can see here, we have our 50 ohm load, and of course we are feeding here with our mini VNA, and so now let's see with the switch out, and I've lifted here. Let me go closer. Here our feeding choke for our DC, and so under that circumstances, let's have a look how it looks like. And I directly go over here to the graph, and what you see is it is fantastic. So now I've repositioned the camera a little bit, and what you see now, we have here really over the entire bandwidth of 30 megahertz. So we have approximately 1. If we go up there, you can see that we really have an SWR of 1.03, which you know is exactly what we are looking for. So no problem whatsoever. But the question is it only the switch and maybe the PCB and this little odd wire which we have seen here at that contact point. So is it only that, or does our choke something or did our choke something have to do with the very, very bad SWR? And that is what we can test as well, because I can push it down here, that it gets a connection. Okay, and well, let's see how that is working out. Okay, and here we have our excellent SWR, as we have tested it before. And now I press back here the little choke to its connection, and let's see what we have then. Wow, and here we have obviously the real problem. So have a look. Our SWR is up to, what is it in the middle? At 20 megahertz. It is 406, but even 21 or 27 is absolutely not acceptable. So that is the reason why it didn't work. So okay, a little bit with the switch, but most or more serious is obviously our choke, which is doing something odd in any way. So let's look deeper into that. So, and I was curious to know what is the inductivity which our choke has. And well, so I'm directly down here at our choke, so I'm testing it over there, and what we test for is 0.3 microhenry, which is on the other hand, don't know if you really can read it, what is on the other hand 300 nanohenry. And that is from the feeling here, that is far too low. And I will explain why in a bit, but I'm curious as well what will be here our first one, and that is turning out to be 0.3 microhenry or 0.2 microhenry as well. So something between 0.2 0.3. So that means this both chokes are in series. So that means we have maximum, let me say 600, 400. Let's calculate with 600 microhenry, and let's see how it turns out. And at the beginning of the video I already said that it is not much to it. So we only have to consider two parameters. So that is the XL and the XC, which is at least the AC impedance. Okay, and I said that our XC, which is our capacitor, should be much lower than our load impedance. And we know that our load impedance is of course 50 ohm, and thus of course it has to be much lower. And on the other hand, I said that our choke should be much higher than our load impedance. And we can calculate it with the formula XL is equal to 2 times P, F and L. And when I just take my 2P and I went into the middle of our band, 14 megahertz, and I was calculating here with 400 nanohenry, which is 0.2 microhenry 2 times, okay, and then I'm getting to 35 ohm for our XL, and that is very, very close to our port or to our load impedance, and that means we do not fulfill the requirement that it has to be much, much higher. And under these conditions, you know, the RF, which is getting into our bias T, is now seeing the output port, which is 50 ohm, and it sees somewhat the parse to our DC input. And remember, at the beginning of the video, I also said that these bias T's are a kind of 3-port devices, okay? And therefore, if we now have on our DC pass, on our DC supply pass, an impedance simply by our shocks, which is very similar to the impedance of our load, then this both impedances gets somewhat mixed up, and we will get a completely wrong SWR what we are seeing. And well, therefore, of course, we can double check here in our antenna tuner. I mean, we have here our choke as well, and well, it is now very much interesting to know what we have as inductance here at this inductor. Is it also 0.2 microhenry, or maybe 0.5 microhenry? I don't believe it. So simply let's go and check, and we then know what's really going on and see what we are testing here. So now we are testing 96.7 microhenry, which is, you know, much better than 200 nanohenry, okay? So 100 microhenry, I would expect it also as a little bit low. I would see something around 300 microhenry. But anyways, we have seen that it was working without any problem. So our radio did not didn't report a high SWR when we were feeding our antenna tuner directly by the radio. So this approximately 100 microhenry must be fine. And look, I've done exactly the same calculation here with 100 micro, not farad, it is of course Henry, 100 microhenry. And the result is that we have, with 100 microhenry, we have 8.796 kilo ohm, and 8,796 ohm is of course much higher than 50 ohm, which is our load impedance, and that makes sense. So if our assumption here is entirely true, that would mean, on the other hand, that, you know, it is a design error. So how we can go ahead? So yeah, I have to take out both to verify that what we have tested is true, and if it is true, then we have to go for another choke, because that definitely doesn't work. Right, so the coils, the chokes are taken out, and you see we can prove our testing result. It is 0.2 microhenry, and that is obviously a wrong pick in factory. So maybe that the person who was putting these parts in are assuming that it is a 0.2 millihenry, which then would be 200 microhenry, so that would make sense. And so I believe this is a wrong pick in the production line. So what we need to do is we need to put in, of course, a different part, and then we have to verify if then everything is fine, and we would not have these problems any longer. Well, I have some chokes on stock, but you know, well, this one here would be most likely fit. It is 475 micro Henry, but it is only 150 milliamps, and our automatic tuner is consuming up to 850 according to our manual. So that is not really sufficient to deliver the constant, let me say, 800 milliamps. So that is not sufficient. This would work. It is 68 microhenry, which would it would be okay, but mechanical, I can't fit it. So what can I do? So what we can do, we can check if it would work with, you know, in circuit, and if we can prove that it works, then of course we can go for a new choke which is able to handle, let me say, 1 amp. That would be fine. I mean, I have here one. This is able to handle 3 amp, but only 8 microhenry, and that is not sufficient. So I guess we put this here in just to prove that our considerations are right, and then I have to order one. No other way. Okay, and that is really good news. So you see, we have really a fantastic SWR over the entire bandwidth we need. And you see what I've done here is I've put in here 2 of these inductors in parallel. So that means they can now handle 300 milliamps, which is still not enough, but it is possible to show that with it is soldered in, and you see it is working. And what we can do for testing, I think we can connect it to our automatic tuner to see how it reacts. Okay, so I'm testing here a little bit around. So first, as we discussed, I have tested here the 475 microhenry, which is from the perspective of inductance not wrong, but we have a too high ohms resistor, which is leading to a reduced current flow to operate at least here our tuner. So therefore I just for testing put in here my 68 microhenry inductor, which is on one hand a little bit too low, but anyways the wire resistance is low enough to operate our circuit. So let me see if I can reposition the camera a little bit to show you how it works. Okay, hope we can see everything with this setup here. Okay, so manually I have here my 12 volt from the power supply over there, and now I put it here to our choke, okay, which happens now, and you see we have our 27, what is it, 23 milliamps. So that is now connected here, and obviously it is working here over our BIOS T. So we can let clip take away, so you have a better view to what we are doing down there. So I'm really supplying now over our BIOS T, our 12 volt to the unit, and that is when I put it here, you can hear that it is clicking. Okay, so on the other hand, we want to see what is happening with our output power. And now let me take my microphone, and I'm feeding it here with my radio, and it is set to 14 watt output, I believe, something like that. And you see it is going through, and you see that the amp meter is changing a little bit, and it is sometimes switching. So let me take it away once again, put it back in. It is switching, and now you see 41 milliamps, and I heard a relay which was not that loud, what we have heard before, but obviously it is adapting the SWR, so it is working over the BIOS T. I'm not entirely satisfied with our inductor here, so I need to find something which fits from the dimensions here, and of course as well from the value. So yeah, I will test a little bit around to find the right values, and then we should be fine. And what we see is that definitely our inductors which were in our chokes here didn't work. So that was a problem why we had such a miserable SWR. So you have seen it was not working at all. Now it is working. It is not perfectly as it is, so we have to adapt it a little bit more, and then yeah, maybe I think I have somewhere some inductors, so I need to go down to the other stock and see what I have, and then we can go ahead. Okay, so I have found here two inductors, chokes, whatever you want to call it, which fits both ways, so mechanically and electrically, because of course we really have to consider our input SWR as well, because our radio should always see a low SWR within the bandwidth where our product is developed for. So therefore, according our manual, it is from 160 meter up to 10 meter, and of course in this bandwidth it should be fine, and therefore we have again here our mini VNA, and we have here our dummy load, which now with the new configuration should give us a good SWR response in this configuration. That is what we want to see now on the graph. And look, here is our response, and we clearly see that so that is where our marker is at 1.8 megahertz, so that is 160 meter, and even down to 1 megahertz we are a little bit over 1.5 SWR, which is fine, but our product is certified from 160 meter, and you see that is 1.27, which is fine. What the driving radio will see, in brackets, when it is connected to our tuner, and you see over the entire, really over the entire bandwidth up to 30 megahertz we are just fine. So something around 1.03, maybe a little bit more, but not too bad. So that is definitely working just fine. So we do not need to think about the radio, which will be connected to our tuner over, of course, our BIOS T. It looks fine, so therefore let's test it in reality once again with the radio connected to it, and let's see if it still works, and if we can put all back into the housing, and it will be fine. Okay, after we have tested our input SWR into the BIOS T, now we are back to the real setup, more or less, so there is no real antenna to it, but anyways. So now we drive our circuit with our radio, and again first we put our DC to the shocks, which you have heard the tuner is switching, and we have our known 23 amps, so that is just fine. And of course now we want to know if the voltage, which finally has really to get down here to our supply point, let me call it that way, should be of course close to our 12 volt DC which we are feeding in, because if it is lower, then it is an indication of, therefore, that too much voltage drops at our shocks, which we had with the 475 microhenry choke. So the voltage drop was too high, and that was resulting in the fact that we only had 8 volt at the supply point. And now let me see if we can, you should be able to see my DMM, and okay, now when I go over, you see that we have 1196 compared to 12 volt which we are feeding in, so that is a clear indicator that we do not have too much voltage drop at our shocks, one hand, and on the other hand the configuration is exactly for this purposes, because our input SWR is at the right amount. So you see, we have to balance it as well a little bit, since it is still a three gate network, which really needs to be balanced a little bit, that we have enough voltage at one end and we have the right SWR. Alright, so that all is obviously working without any trouble, so we really get our power through. When I pull here, you see it is working just fine, and even if I go and increase my output power, you see that is working as well. So I can increase it anymore. You can see it here. Everything is working just fine. So that definitely means that our configuration as it is now is working fine, and we definitely can now put it back into our case. We have to put, of course, the switch back, and yeah, then it is ready to go. And the next I will do, I will put it into the box. I will finally complete everything as it should be, and then I will be back. Alright, everything is ready for final testing, and it is prepared already. So you see here our bias tee is back in its little box, and now I switch the power switch, and you already heard that it is working. And when we first tested it, we saw that we didn't get any power through our tuner. And now let's have a look. And you have heard it switching, which is very nice. So you see 50 watt, I've dialed in approximately 55, I believe. So our SWR at the LP 500 is 1.05, and you see everything is working as it should. So let me switch here maybe to 14 meter band, and let's try it once again, and still no, I have to push it here once. Yeah, and you see it is working just fine without any problems, and we do not see here our SWR bar which went up to the max, so that is fine, no problem whatsoever. So I would say that was a success. I have modified the board here a little bit so that we do not have ground anymore here in any way from the switch, and I have isolated the switch from underneath so that it cannot get in contact with the PCB. Therefore, yeah, I mean, now it is lifted up a little bit, and that means that here our plug goes in a little bit stronger, but that is not really an issue. More important is that it is isolated here from ground, and that is given now. You see here the new components in, and you have seen it is now working just fine. Anyways, thanks for watching, and catch you next time. Bye.